Let's look at sample problem 9.12, calculating the pH from hydronium concentration. And you're asked to determine the pH for the following solutions. Hydronium concentration is 1 times 10 to the minus 9 molar, and hydronium concentration is 4.5 times 10 to the minus 7 molar. And let me just talk a second about significant figures. When we're looking at significant figures for pH, we look at the values after the decimal point. So since my first hydronium concentration only has one significant figure, my final answer will have one place after the decimal point. And then my second concentration has two sig figs, so the answer will have two decimal places after the decimal point. So pause the video to calculate the pH of these two solutions. So if we look at our first concentration, I really don't even need a calculator because this is a multiple of 10, 1 times 10 to the minus 9, and so the pH is going to be 9. But if I look at my calculator, I take the log of 1 times 10 to the minus 9, I take the negative of that, and I get 9. And since I have one significant figure, I would express my answer as 9.0. And that makes sense. My concentration of hydronium is 1 times 10 to the minus 9. It's a concentration less than 1 times 10 to the minus 7. So I would expect a basic pH. And 9 is higher than 7, so that's a basic pH. Looking at my other concentration, if I take the base 10 log of 4.5 times 10 to the minus 7, and I take the negative of that, the pH I get is 6.35 to two significant figures, and that is an acidic pH, which is what I would expect since my original concentration is greater than 1 times 10 to the minus 7.